Okay, let's get going. So this is where we got stuck. If you remember, we were counting the number of functions. We counted the number of functions and we counted the number of one-to-one functions. ये हम नहीं कर सके. Oh, did we? We did this, right? इसके आगे वाला नहीं हुआ था हमसे. ये वाला, है ना? Does anyone remember what's the number of functions from a set on n elements to a set on m elements? M raised to power n. Okay, so the size of the codomain raised to power the size of the domain. Okay, and here's the problem that I said is trickier to solve. It's not that easy. Okay, it requires few tools, techniques जो हमने अभी तक नहीं देखी. Okay, so let's go and see what those tools and techniques are. Those individual tools and techniques are super simple. Okay, but the proof itself is going to be, I think it's probably the most involved thing we have seen so far. Okay, so I want you guys to pay attention. So this is a bit tricky, and here's the first rule. The first tool, you already know this actually. So this says that if you want to find out the cardinality of a set, okay, and you know the cardinality of its complement, then you are in good business. Okay, then all you need to do is universe की cardinality find out कर लें, उसमें से complement निकाल दें. Okay. So far so good? Simple enough? Alright, the second tool is also known to you. It's called principle of inclusion exclusion. That if you want to count the cardinality of union of a bunch of sets, if you know their individual cardinalities and cardinalities of their intersections, then you are good. Okay? And at times that's what you need. Okay, ये हमने discuss किया, so I'm gonna just skip through these slides, and then we will do the proof on the slides. Okay, on the board. Okay, it's important that all of you can see the board today. Can you see the words written on the board? Yes. Okay, if I start writing from here, everyone, Ryan, your seat is over there. Why are you sitting in here? Hurry up. Your permanent seat is over there. Alright, so this is what we seen last time. That if you have three sets, उनके union की अगर आपने cardinality find out करनी है, तो you take their individual cardinalities, subtract cardinalities of intersection of pairs, and then add the cardinality of the triples. Okay? If there are four sets, what you are going to do is you are going to add the cardinality of individual sets, subtract the cardinality of pairs, add back the cardinality of triples, and then subtract the cardinality of intersection of all four of them. Okay, so it's you increase the cardinality of sets that are being intersected, and then you change the sign. Okay, so पहले आपके पास ये 1 cardinality के सेट्स हैं, ये ऐड हो रहे हैं, उसके बाद 2 cardinality के सेट्स हैं, ये सब्ट्रैक्ट हो रहे हैं, उसके बाद 3 cardinality के सेट्स हैं, ये ऐड हो रहे हैं, उसके बाद 4 cardinality के सेट्स होंगे, वो सब्ट्रैक्ट हो रहे होंगे, and so on. Okay? Yes. Yeah, sure. So what I'm saying is that when you go to, in general, what happens is that if you want to find out the cardinality of union of n sets, okay, and then you have sets Si, if you want to find out this thing, okay, you would want to either sorry. Mr. Eraser is okay. You would change the sign at every turn. Okay, jab I okay, I'm gonna start I from 1. Okay, so when I is 1, this would be positive. When I is 2, this would be negative. When I is 3, this would be positive. When I is 4, this would be negative. When I is 5, this would be positive. When I is 6, this would be negative. Okay, so I'm switching the sides, and then I'm taking the intersection of all I pairs, I tuples. Okay, so when I is just 1, so you would get just one set here. Okay, but that once one cardinality set. Okay, जब आपके पास I2 होगा तो you would get pairs, दो दो के आपके पास इंटरसेक्शन होंगे, जैसे यहाँ पे केस है ना, जब I आपके पास 3 होगा तो यहाँ पे ट्रिपल्स हो जाएंगे, जब I4 होगा तो यहाँ पे आपके पास quadruple होंगे, and so on. Okay, so when you're looking for union of 4 sets, you would first have again negative I raised to power. अब I once से सब start करेंगे तो you would get 1 plus 1 and you would have individual sets. Okay, so you would get cardinality of, I'm using S, so I should write S here, S1, and then you would have plus S2 plus S3 plus S4. Okay, उसके बाद next जो इसकी टर्म होगी उसके अंदर negative I raised to power 2 plus 1 हो जाएगा. Okay, and you would get pairs S1 intersection S2 plus S2 intersection S3 plus S1 intersection S4, I don't know, in no particular order, S3, S2 and 4, S3 and 4. Okay, these are all pairs. Okay, again फिर इसकी जो next term होगी इसके अंदर you would get negative 1 raised to power 3 plus 1. Okay, and you would get S1 intersection S2 intersection S3. Okay, and you would get S1 intersection S2 intersection S4. Let me use this space as well. S2 intersection S3 intersection S4. There should be one more set. 4, 1, 3 तो 2 को मिस करना है. S1 intersection S3 intersection S4. Okay, so these are triples, and then the last thing would be negative 1 raised to power 4 plus 1, and then intersection of all 4 of them. Okay, S2 3 intersection S4. Okay, so what's happening is that I am adding these things. Okay, then I'm subtracting these things, and then I'm adding this thing, and then I'm subtracting this thing. Okay, so in general, if n is large, this is what you do. You increase the cardinality, switch the sign. Increase the cardinality and switch the sign. Okay, that's how pi works. So this looks much complexer than it actually is, much more complex than it actually is. Okay, but the concept itself is simple. Okay, any questions? Brian, are we good? Okay, cool. So this is the picture for 3 sets. We have already seen this. Okay, is the example जो हमने पहले से देख ली हुई है. Here's the tool 3. The third tool is combinations. The people who studied math in high school know this already, but this term is used for choosing R people from a set of n people. Okay, so if I want a committee of 3 people from this set, what I need to do is I need to choose those. There are many different ways to choose those 3 different people. Okay, and that is represented by something called a combination or combination. Okay, and this is how we denote them. We call it n choose k, and here's the formula for it. Forget about the formula. We'll talk about the formula later when we come to counting after the midterm. It will become very clear, but for now what I'm doing is I'm just giving it a name. Okay, मैं सिर्फ उसका एक नाम रख रहा हूँ कि number of ways to choose r things from n things is n choose r. Okay, it's just the name of that thing. Okay, what that thing is actually equal to, we don't care at this point. Okay, are we good? Yes. All right, so these are the 3 tools that we have, and now we have to prove this thing. We want to count the number of surjective functions from a set of A things to a set of B things. Okay, let me मैं इनको N और K कह देता हूँ अभी, ठीक है, just to kind of pronounce them easily. I'm gonna not use this thing here, तो हम यहाँ से start करेंगे, but we'll do it on board. कहीं पे भी stuck हो जाए तो you let me know, okay? All right, and I'm gonna ask your help at almost every step. So we'll walk this together. Again, I'm gonna need a kind of a useless graphic. So the graphic says that I have n things here, and I have k things here, and I'm looking for surjective functions. Okay, what that means is that everything in here must be mapped. You cannot leave anything here unassigned to anyone here. Okay, cool. So if I use the first tool, what does that mean to me? Yeah. So say it.
Subtract the complement cardinality from the equation set.
Cool. So इस केस में इसका क्या मतलब है? इस केस में इसका क्या मतलब होगा?
यूनिवर्सल सेट में से n यूनियन k की से complement subtract.
Okay. Think a little bit more. Okay. So this is what we want. We want. Let me call this. Let S. Am I using S anywhere? No, I'm not. Okay. So S be SNK be the number of. I said I was not going to use this, but I'm going to use it anyway. Okay. SNK is the number of surjective functions. A to B, where size of A is n, the size of B is k. Okay, so S and k is the number of surjective functions. This is what we are looking for. Okay, this is what we want. So what do? And I said I'm gonna use the first tool at this point. So what do? Yes.
यूनिवर्सल सेट में से k की cardinality minus कर देंगे और इस तरह यूनिवर्सल सेट में से n minus.
Okay, it's much simpler than that. What I'm asking you guys to do is much simpler than that. I want to find out S and K. It looks like I have no idea how to compute S and K. So what do? Let me try to find out complement of S and K. Kind of complement, okay? Because S and K is a number, तो इसका complement तो defined नहीं है. What I'm saying is, instead of computing the number of surjective functions, let me compute the number of non-surjective functions. Okay? Then I know total number of functions, उसमें से मैं निकाल दूँगा. Well, so what's the union now? What's the union? What's the size of union? इस example में union is all functions, right? And we know number of all functions. Okay? That's k raised to power n, right? That's the total number of functions. Okay? So instead of computing S and k, I'm going to compute. Let me define u to be. Or did I use u again? Let me use. Let n be the number of non-surjective functions. So I'm going to define this as u minus. Okay, I'm going to use this as set because I have real trouble handling this. Okay, so this is the set. Okay, set of non-surjective functions is union minus S and k. Okay, which means that S and k is also union minus n and k. Okay, this I already know. This I need to figure out. Okay, so now my problem is to count non-surjective functions. Am I writing very small? People at the back, can you guys read this? Okay, so I'm counting the non-surjective functions now. Okay, what's going to be the property of non-surjective functions? They must leave at least one of these unassigned, unrelated. Okay, यहाँ पे कम से कम एक यहाँ पे होना चाहिए कोई चीज़ जो किसी को असाइन नहीं हुई होनी चाहिए. Okay, that's the way to do it. उसके अलावा कोई शर्त नहीं है. Okay, all right, let's pick something here. उसको इसमें से निकाल देते हैं and then find out number of functions from here to whatever remains. Okay, so here's our plan. Plan का part 1 is remove one member or item from B and call it I don't know, B1. Okay, count all functions from A to B1. Okay, अब since B1 में से कुछ निकला हुआ है, these functions must all be non-surjective. Are we good? Am I going too fast? Questions? Hanan? Ans? Ryan? Fatma? Zoha? Ibrahim?
S number of surjective functions and non-surjective.
So S is set of surjective functions. Okay, so इसकी जो हम ऐसे कर देंगे तो उसकी cardinality हो जाएगा. ठीक है, n set of non-surjective functions. पूछो और पूछो कुछ. Let's continue the conversation. अब तुमने कुछ बोल दिया तो I'm not gonna let you go. So what's going on? How are we trying to find out the cardinality of S and K?
हमने उसका कॉम्प्लीमेंट लेकर उसको माइनस कर देना यूनिवर्सल.
हाँ, और यूनिवर्सल की कार्डिनैलिटी हमें
दोनों के टोटल निकाल के आगे पावर से.
हाँ.
सर सर्जेक्टिव तब भी तो होगा अगर 1 to 1 रिलेशन ना हो.
1 to 1 का सर्जेक्टिव से कोई ताल्लुक नहीं है. You have a function. It's possible to have a function that's 1 to 1 and not surjective. It's possible to have a 1 to 1 function that's surjective. 1 to 1 का सर्जेक्टिव से कोई ताल्लुक नहीं है. Okay? ठीक है? Yes? Yeah. Okay, so हमारा पहला जो हमारा स्टेप A था ना, स्टेप A ये था कि हमने पहला टूल अप्लाई करना है. Instead of counting the number of things in my set, I'm going to count the number of things that are not in my set. Okay, and that's fine, right? That's great. जो second part है, अब मैंने वो चीज़ count करनी है जो मेरे set में नहीं है, right? And I told you किसी चीज़ का मेरे set में ना होने के लिए इतना काफ़ी है, नॉन सर्जेक्टिव होने के लिए इतना काफ़ी है कि अगर यहाँ से सारी की सारी चीज़ें यहाँ पे मैप हुई हुई हैं, लेकिन देयर इज़ एटलीस्ट वन एलिमेंट जो नहीं मैप हुआ हुआ. ओके, तो आई विल गेट अ सर्जेक्टिव फंक्शन. ओके, और सारे सर्जेक्टिव फंक्शन इसी तरह के होंगे. ओके, सो आई एम गोना काउंट नॉन सर्जेक्टिव फंक्शंस by removing one element from my codomain and making sure that my range does not include this. Okay, so if I count the number of functions from set A to set B minus one element, I would be good. I would be counting the number of non-surjective functions. Yes. That's also a possibility. Okay, so that's why what I'm saying is that I'm not restricting you to only discard one element. एक से ज़्यादा एलिमेंट्स यहाँ से पिक कर. So here's the thing. A non-surjective function. This is let's kind of make a concrete example. I was avoiding it, but let's make it anyway. Okay. So 1, 2, 3, 4, 5, whatever. Okay. Here is an example of a non-surjective function. Okay. It's a non-surjective function, and it is valid for my definition. मेरी definition ये थी कि इसमें से कम एक element होना चाहिए जो assign नहीं हुआ होना चाहिए. Okay, and I can pick that element to be 5. Okay, अब 5 के साथ कोई assign नहीं होना चाहिए. बाकी कोई 1 के साथ assign हो, 2 के साथ हो, 3 के साथ हो, I don't care. As far as 5 के साथ assign नहीं होगा तो I would get a function that's not surjective. Alright? Does this kind of answer your question? No? Yes? No? हाँ बोलो. Okay. Okay. But that's not all surjective functions, ना? है ना? हमारा गोल क्या है? हमारा गोल ये है कि हमने काउंट करना है कि टोटल कितने सर्जेक्टिव फंक्शंस हैं. ओके, सो आप एक तो सर्जेक्टिव फंक्शंस बना देंगे. ओके, बट दैट्स नॉट काउंटिंग ऑल पॉसिबल सर्जेक्टिव फंक्शंस, है ना? सो दिस इज अ सर्जेक्टिव फंक्शन इफ आई रिमूव दीज. ओके, but if this is my domain, if my domain codomain has k elements, so here how many surjective functions do I get? Okay, I'm not constructing surjective functions, but even if I were constructing surjective functions, if I had a systematic way to count create surjective functions that helps me counting, that would do too. Okay, but what I'm saying is there is no systematic way. मुझे ऐसा कुछ नज़र नहीं आता कि हम construct कर सकें. इसमें से elements remove करके हम कर सकते हैं, but that's not allowed. Okay, वो भी आप कर सकते हैं, लेकिन उसको भी थोड़ा सा सिस्टमेटिक होना चाहिए. ओके, क्योंकि अभी हमने क्या किया, अभी हमने एक एलिमेंट यहाँ से रिमूव किया है और हमने ये कहा कि अगर ये वाला एलिमेंट हम रिमूव कर दें तो जो भी फंक्शंस यहाँ पे बन रहे हैं वो सारे के सारे नॉन सर्जेक्टिव होंगे. ओके, ये वाला काम भी हम आर्बिट्रेरीली नहीं कर सकते. ओके, who gave us the permission to remove 5? Okay, we need to do this more systematically. Okay, we need to be allowed to remove any of these elements. Okay, ठीक है? Cool. So the number of ways, yeah, बोलो. इब्राहिम है ना?
Professor, one more thing.
क्या?
Surjective बोलते हैं इसमें codomain के हर element
Assigned हुआ होता है.
link हो.
Yes.
Remove करने से बाकी सारे elements तो रहेंगे. How about adding an element वो किसी के साथ like domain में link नहीं होगा? I'm confused about the part of removing an element.
Sure.
Like
Okay.
if we
Okay.
remove 5, 1, 2, 3, and 4 might still be connected to every element in the domain.
Sure. If I remove 5, if I say that when you are trying to construct your functions, you are not allowed to assign anything to 5. Okay? अगर मैं ये कह दूँ तो फिर जो भी आप फंक्शन बनाएंगे वो सर्जेक्टिव नहीं होगा, है ना? मैंने कहा कि मैं ये वाला रूल अप्लाई करूँगा, उसके बाद फिर आपको कहूँगा कि खुली छुट्टी है, जो अपने फंक्शंस बनाने बनाए, सिर्फ 5 को असाइन नहीं करना अपने कोई भी मेंबर. ठीक है? ऐसे अगर मैं ये वाला रूल रिस्ट्रिक्ट कर दूं तो जो भी आप फंक्शंस कंस्ट्रक्ट करेंगे वो सारे के सारे नॉन सर्जेक्टिव होंगे, है ना? ठीक है? अच्छा, अब मैंने थोड़ी देर पहले कहा कि यू कैन नॉट नॉन सिस्टमेटिकली आर्बिट्रेरीली रिमूव 5. You should be allowed to remove any one of them. Okay? So for example, if I restrict 4 and I say that you are allowed to assign anyone but not 4, so that's also a non-surjective function. Okay? If I do this for 3, that's also a non-surjective functions. Okay? First of all, if I remove 5, how many functions do I get? Yeah, I get 4 raised to power 4 or k minus 1 raised to power 4 functions. ठीक है? And all of them are non-surjective. Okay? But I get exactly same number of non-surjective functions if I remove 4. I get exactly same number of non-surjective functions if I remove 3. Okay? So the number of non-surjective functions using this rule is going to be equal to, who is going to tell me? Now you are going restricted to use k and n.
K minus k whole power.
Raise hands.
Minus 1 power.
Yeah, you're good. It's k raised to power k into k raised. Oh boy, let me write it down and you can read it. Okay. Okay, so this is the number of functions that you get if I hide one of the elements. Okay, and that's the number of ways to hide one element. All right, are we good?
I can get this one and multiplied k.
Because I can get this k times. So I can hide 5, okay, that's one way. I can hide 4, that's another way. So there are 5 ways to hide one element. Okay, so it's 5 times the number of functions I can make from n to k minus 1. Okay, so k is kind of 5 here.
And one more question, what is the difference between onto and surjective? Are they the same?
Onto and surjective are same. Yes. Yeah. So in this case it would be 5 into 4 raised to power n. Okay, are we good? Yes. So far so good. Munib, Nimal, Hasnan.
प्रिंसिपल ऑफ काउंटिंग का है
Sorry, what?
किया था कि मेरे पास इतने नंबर ऑफ सॉल्व्स हैं टी-शर्ट्स में
वो भी अप्लाई किया. ओके, सो मल्टीपल वेज हैं उसको देखने के. एक तरीका ये है कि आई फर्स्ट ऑफ ऑल चूज़ द नंबर ऑफ वेज आई कैन हाइड एन एलिमेंट, और उसके बाद I choose the number of functions I can make the remaining set. Okay, so it's the number of k is the number of ways I can hide one element, and k minus 1 to the power n is the number of functions from n to k minus 1 set.
लेकिन इसमें कुछ फंक्शन सेम भी तो आ रहे हैं, जैसे कि मैं 5 को हाइड करके सारे
Absolutely. Awesome. I'm so happy to hear this. So this is a really good number, but there's a problem, and the problem is what he just said. I'm gonna kind of spend next couple of minutes explaining that problem. But does anyone else also see the problem?
Yes, sir.
What's the problem, Ibrahim?
रेपिटेशन
बोलो कौन सी क्या repetition है?
जब आप दो नंबर रिमूव कर दोगे तो स्पेस में 1 2 3 4 5 से मैप हो सकता है, तो वो कंडीशन तो उतना कॉम्प्लेक्स
Yeah. So the thing is good. Yeah.
मतलब ये वाली बात है कि फैक्टोरियल होगा के -1
Sure, totally agree. So what's happening is that when I hide 5, I'm counting all functions from this set to this set. उसमें वो वाले functions भी हैं जो इस set से 1 2 3 के ऊपर मैप हो रहे हैं. Okay? So उनको मैं काउंट कर रहा हूँ. लेकिन जब मैं 4 को हाइड करता हूँ तो उस वक्त भी वो वाले functions काउंट हो रही हैं which are mapped from this to 1 2 3. Okay? So बहुत ज़्यादा ओवर काउंटिंग हो रही है. Okay? So what do? We apply pi. Now we apply pi. Okay? So I want to count अब मेरे जो original sets हैं those are now surjective functions from my domain to a restricted codomain. Okay? And I want a union of all of them. Okay? I just want to count the non-surjective functions. अब उनका जो intersection है वो non-empty है. Okay? So let's figure out कि उसको कैसे करना है. Okay? So अब हम ये करेंगे. So these are the functions from my domain to my codomain where one of the elements is excluded. Okay? अब प्रॉब्लम ये हो रही है कि इसमें वो वाले functions डबल काउंट हो रहे हैं जो दो एलिमेंट्स हाइड करके बनते हैं. Okay? So let's count those functions. Okay? These are the functions from domain to my codomain where I have hidden 2 elements. Okay? How many are there?
2k
So this is going to be restricted. Okay? So हमने इसमें से माइनस करना है. There are going to be k choose 2. Okay? Remember ये हमने नाम रखा था number of ways to choose 2 things from k things. Okay? Time k minus 2 raised to power n. Alright? Are you good? Done? Done?
नहीं, इसके बाद हम करेंगे ना 3 को भी माइनस
क्या ये करने से ये होगा कि जो 3 एलिमेंट्स को हाइड करके सेट बनते हैं अब वो बिल्कुल रिमूव हो गए हैं. वो उनको अब दोबारा हमने ऐड करना है. ओके? सो वी गोइंग टू डू k choose 3 raised to power k minus 3 raised to power n. Okay, and so on. Okay, so your formula is going to be, let me write it down. This thing I goes from 1 to n. Okay, it does not hurt to write n. K choose I times k minus I raised to power n. Okay, that's the number of functions that are not surjective. Okay, and the number of surjective functions is now going to be what? Yeah, it's going to be this thing. Let's call it static. It's going to be k raised to power n minus static. Okay, and that's it. That's mic drop. Hanan.
फॉर्मूला में -1 to the power I plus 1
हाँ आएगा 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 बिल्कुल आएगा बिल्कुल आएगा. This would be -1 to the power I plus 1 आएगा, right? Because the first one is positive, so I want that to be positive. Second one is negative, third one is positive, and so on. Okay. इसको आप उसके साथ combine करके अगर लिखेंगे तो you can write this thing as I goes from 0 to n. Yeah, -1 to the power I, k choose I, k minus I raised to power n. Okay, when I is 0, this thing becomes k raised to power n. All right, so this is kind of in my view something tangible and non-trivial that you constructed from things that were very simple. Okay, to for example say कि एक set की cardinality can be figured out from this cardinality of its complement. It's quite a simple concept. Similarly, pi on itself is a very simple concept. Okay, also this is just yeah, it's a number जो हमने अभी नहीं पढ़ा कि ये क्या है, पर उसका हमने नाम रखा है. Okay, it's usually very important at mathematics to name things. It's usually probably the most important part of the math, to name things, to give them reasonable names. Okay, Hanan.
लास्ट स्टेप की समझिए कि k minus static
ये वाले की या ये वाले की? ये वाले की. Okay, so हमने count किया this static thing is number of non-surjective functions. Okay, and this is the total number of functions. इसमें से हम non-surjective functions निकाल देंगे तो you would get number of surjective functions. Okay, and this I said is equal to this thing. Okay, because when I set I to 0, I would get k to the power n from here. Okay, जब आप माइनस करेंगे तो आपके सारे साइन स्विच हो जाएंगे, राइट? तो यहाँ पे i plus 1 की बजाय आपको i करना है. Very good. Yes.
जो आपने n is it the part of formula?
Yes. Yes.
ये n के मतलब वो combination बना.
No. It's k raised to power n. It's k raised to power n. It's the number of functions from n set to k set. क्या?
Static के बाद.
Static के बाद जो लिखा हुआ है, sorry my writing. This is second chapter. So these two things are equal. Okay. Questions, complaints, comments? Do you guys like this thing or what? Does not make sense? Stupid है क्या है? Comments? Yes, no? Comments? ओके मैं इसको थोड़ा सा रिसर्च करूँगा फिर I'll come back to it, okay?
बायोनॉमियल से भी जाना है
Yeah, I don't know. Okay, so this thing is called, I think this thing is called Stirling's number of second kind, if I remember correctly. Okay, I'm kind of SNK, and it has. अब इसको सर्च करेंगे तो you'll see कि इसकी क्या applications हैं. Okay, Stirling's number of second kind. It's the most important kind of Stirling's number. Okay, first kind is not that important. Bell numbers. Yes, no comments. I see few smiles, so that's good encouragement. Have you guys seen Avatar series? Not the movie, series. You haven't seen the series? हाँ. Sorry, what? Airbender, yeah, the Airbender series. Okay, so उसमें ना start में, if you remember, the way he is chosen to be Avatar is उसके सामने वो कुछ चीज़ें वो रखते हैं, and he picks the things जो उसने previous lifetime में whatever use की होती हैं. Okay? So this is that kind of test. Okay, I presented it in front of you. If any of this makes sense, then probably this line of work might be something to consider. Okay? Munip, yeah.
हम ये कर रहे हैं कि ये हमारे पास जो एक्स्ट्रा एलिमेंट्स हैं उसमें से एक रिमूव करते हैं, फिर जो नंबर ऑफ पेयर बचते हैं उसको माइनस करते हैं, या नंबर ऑफ वेज 2 के 3 के 4 के प्लस करके तो 5
वो दोबारा रिफ्रेश करो. So I want you to remember this number. Okay, this is where we started. This is where kind of we came into this word. Okay, so this is 5 times 4 to the power n. Okay, does this number make sense to you? Do you know the meaning of this number in the context of what we are doing? No? Okay. So 5 is the number of things here, okay? And 4 is the number of things here minus 1. Okay? Because यहाँ पे तो मैंने कहा कि n है ना, यहाँ पे 4 नहीं है, यहाँ पे n है. Okay? So this number is number of surjective functions in our original calculations. Number of non-surjective functions from here to here.
लेकिन हमारे पास एक्स्ट्रा है,
फिर एक्स्ट्रा वो हमने फिर बाद में किया. But this should make sense on its own if you forget about the repetitions. Okay? फिर हमने ये कहा कि
ये जो चीज़ है कि एक इवेंट था ना, ये अगर हमारे पास एक एक्स्ट्रा होती है उसमें,
yes,
फिर अब हमारे पास 2 एक्स्ट्रा है, हमने अगली का
yes, yeah, absolutely. So this is the thing which is the number of non-surjective functions, but with overcounting. Yeah, but with overcounting. Okay, and this is that overcounting removed. Okay, but this is over removal now. Okay, over killing it. Okay, and this is adding back that number जो हमने यहाँ से extra remove किया. Okay, but this also adds an overcounting. नेक्स्ट स्टेप में हम रिमूव करेंगे और नेक्स्ट स्टेप में हम उसको निकालेंगे. इफ़ यू रिमेंबर, मैं आपको पिक्चर पे उसकी ले जाता हूँ. वेयर इज़ दैट? डिड आई कहाँ? ओ यार, इसको क्या हो गया? सो दिस इज़ द पिक्चर ना. ओके, सो हमने ये सारा कुछ काउंट करना था. तो हुआ ये कि हमने जहाँ पे ओवरलैप हो रहा है उन चीज़ों को हमने 2 दफ़ा काउंट कर लिया. राइट, हमने इस वाले सर्कल को भी काउंट किया, उस सर्कल को भी काउंट किया. जब हमने इन दोनों सर्कल्स को काउंट किया तो फिर यहाँ पे जो चीज़ थी वो डबल काउंट हो गई. ओके, अब ये करने के बाद फॉरगेट अबाउट दीज सर्कल्स नाउ. ओके, नाउ यू हैव दीज ओवल्स. ओके, इन ओवल्स को हमने एक दफ़ा रिमूव करना है. ओके, बट इफ़ आई रिमूव दिस ओवल एंड दिस ओवल एंड दिस ओवल, तो इस वाले पार्ट को मैंने 3 दफ़ा रिमूव कर दिया. ओके, विच मीन्स कि इसको मैंने 3 दफ़ा काउंट किया था, 3 दफ़ा रिमूव कर दिया तो ये काउंट ही नहीं हुआ. ओके, सो इसलिए मैंने इस पार्ट को एक दफ़ा फिर ऐड करना. ओके, सो दैट्स व्हाट्स हैपनिंग. जब आपके पास ज़्यादा हो जाएंगे सेट्स तो उसकी जो ओवर काउंटिंग है वो आपको बार बार देखनी पड़ेगी. ओके, सो आपको एक दफ़ा ऐड करना पड़ेगा, फिर रिमूव करना पड़ेगा, फिर ऐड करना पड़ेगा, फिर रिमूव करना पड़ेगा. दैट्स हाउ यू गेट रिड ऑफ ओवर काउंटिंग. ऑलराइट.